Thank you. What I'm going to do is I'm going to build on the last talk and take a look at some of these technologies that were talked about. And as Dave says, I'm going to look at it from kind of a critical point of view. I need to start with I'm government employee, but my opinions are being expressed today and not those of the U.S. government. So let's start with the one that we just heard a fair amount about, which was edible insects. And let's take a little deeper dive in edible insects. We had a meeting up at Tufts University a few years ago, and the paper came out of that. And basically it says it's appreciation for the potential benefits of insect-based foodstuffs to individuals, society, and sustainability of the global food supply. So let's look very carefully at insects then. Some of the claims that are made about insects: higher food conversion efficiency, twice as high as chicken and pork, 6 times that of cattle, higher percentage of consumable and digestible mass, 100% of crickets if you grind the cricket up and throw it in, lower water requirements, lower greenhouse emissions. I think one of the problem with, and I'm going to talk about some data like this for some of the others, there's no real metrics around how we really do the life cycle analysis on this. So you get, depending on who's doing it, you get a wide range of numbers out there. Let's start with what is an insect. As was stated earlier, there are a number of insects that are out there. There are a lot of larvae. There are the whole insect like the cricket. And why insect? One of the things that's pointed out with insect is the nutrition of insect. So this graph, this 3-part graph, shows you the protein, lipid, and carbohydrate content of a number of different ones: house cricket, mealworm, a couple of moths, soldier fly, and housefly, the larvae of those two. And as you can see over here on the right-hand side, you can see that, does this have a pointer on it? Is that it? No, it's not working. As you can see, this is where most of them cluster right in here. They're fairly decent sources of protein, and they have a fair amount of lipid in them. So, this is pointed out, it's a great source of protein. We can utilize them down the line. And the problem is, if you do a little deeper dive on that, you find some problems in the nutritional composition. For example, what this shows you here takes a number of the different proteins, and let's just look at 2 insects, the mealworm and the house cricket, and let's compare it with beef and pork. So the mealworm and the house cricket are these 2 brown bars right here. The beef and the pork are the dark and the gray bars. And what you can see in a lot of cases for several of the amino acids, they're very similar. But then let's take a look at some of the ones that are limiting in plants. And you find that, for example, lysine tends to be limiting in the insect. Methionine also tends to be limiting in the insect. And also tryptophan can also be limiting. So these are some of the same ones you might find in a plant. By the way, I should point out where these data are coming from. These data, the research in insects have been mainly done by people who were studying insects as a pest. So a lot of this is coming out of our research facility where people have had to learn, our scientists have had to learn how to rear insects in large quantities in order to study them as a pest. Now, the food companies tend to be coming out of the pet food industry where they rear lots of crickets for sale for your pet lizard. But they haven't really meshed the two and looked at some of these outstanding problems. So in this case, they ran, this group did a number of experimental diets. I won't go into them, but there's a controlled diet, and there are 4 diets. And let's take a look at what the result of that is. So when you do that, first of all, they talked about conversion efficiency. Well, conversion efficiency depends on diet, for one thing. There is no standard diet. There's no understanding of what is really needed dietary-wise. And then if you look over here, reproductive rate is really impacted by diet. You know, it's going from 100 to 450, you know, depending on diet. So there are obviously some big questions around diet and what's the best way to rear these. How about nutritionally? So here you take a look at the different diets and you look at the fatty acid content of these in the different diets. And the one thing you can immediately see is there are enormous differences in fatty acid content depending on the diet. So very similar to fish, the insect fatty acid profile is going to be what they get out of the diet. And obviously, if you're going to be using insect as a food, there's got to be some kind of standard of identity. There has to be some kind of standardization of process. Here's another slide looking at the nutritional content. And over here on these columns, you see the amount of an amino acid in the diet. Over here, the amount of the amino acid in the insect. So just take the first line, and the thing you notice is that arginine in the insect is highest in the ones that were fed the diet highest in arginine. So once again, it depends on the diet. An insect is kind of a blank box. The big thing, it affects the production. As I showed you earlier, the reproductive efficiency changes. In this case, there are other things that affect reproductive efficiency, management conditions. This, for example, is just how crowded the insects are, the amount of adults per meter squared. And you can see that reproductive efficiency, there's a maximum and then it tails off. So you've got to have some standards around the industry. Here's another one showing changes in reproductive efficiency. In this case, it has to do with the age of the insect. Well, the other question is, what are you going to use? So, as was mentioned earlier, most is cricket powder. You take the whole cricket and you grind it up and you utilize it. But a protein isolate would be much better to use. But as far as I know, as well, I don't know of anyone doing that. It's cricket powder because, as I said, most of these are coming out of the pet food industry. They have lots of crickets, so they dry them and grind them and sell them that way. These data are coming from a company in France called Chopin. Dr. Arnaud Dubé allowed me to use the slides for this. And what they did here is they went out and they got 3 different cricket powders, and then they put them through some functionality tests. So I won't go into what the tests are because that's immaterial, but what it shows you is that the 3 different powders behave very, very differently. You see it in that slide, and in this slide, you really see it, the way the different powders behave extremely differently depending on what you're doing. So you can't develop one process for cricket powder because there is no standardized cricket powder. The other thing this group did is they did a baking test with it. It done in France, so it was done in French bread. And the one thing you quickly notice as you add cricket powder, it becomes very dark. I was also told a very different taste. What they concluded from this is up to about 2.5% incorporation was the maximum you could get into bread before you got unacceptable characteristics. So nutritional considerations. First of all, the regulatory status is uncertain. It's operating in kind of a blank space right now. There is no guidance for industry. So as it becomes bigger, obviously it will trigger notice by regulatory groups, and you'll see more of it. How about anti-nutritionals? We heard about the heavy metals, but chitin and chitosan, these are important. This is important. This is in the exoskeleton. It's sold as, chitosan is sold as a dietary supplement right now, but we really don't know what the effects of chitosan. Is it an allergen? Does it inhibit other nutrients? Does it act as an anti-nutrient? So those things have to be answered. So in summary on insects, the gaps and challenges, first of all, to optimize production, you have to optimize production methods and processing technology. Secondly, the health impacts. They're being sold as though they could be better for us, but we don't have any data on that right now. So that certainly has to be looked at. Is there any benefit compared to a conventional food source, especially if you eat it regularly? On the other hand, is there any negative if you eat it regularly? You know, are there anti-nutrients, food safety concerns? And finally, the market development. There's an aesthetic aversion to insect consumption. You have, how are we going to get around that? And it may take years to get there. I think there is a segment of the population willing to try it, and that's probably where it'd have to be built from. So from that, you have to decide what the entry point markets would be and the marketing approaches. And then you have to decide what insects, what are you going to actually push? So let's move on to another technology, and let's go to plant-based meat alternatives. And plant-based meat alternatives are chosen by consumers for two reasons. They're chosen for nutrition, and they're because they see it as more nutritious, and they choose it because they see it as more sustainable. So this is the pitch that you get. This is from the Impossible Burger website, and the Impossible Burger website did a life cycle analysis, and from that they conclude that compared to beef, there's a 92% decrease in aquatic eutrophication. There's a 89% in global warming potential, 96% decrease in land, and 87% in water consumption. However, there's going to be some pushback as this comes back. So let's take a look at some of the actual data on this. So this is data from a group that look at scenarios where this is the percent of animal protein in the diet, and it goes from 0 to 80. And then let's choose one population size, and this population size is 25 million. And so 0% animal protein in the diet gives you a relative land area of 102. However, you notice up to 25%, it's still less land area if you utilize animal source protein. And in fact, what they conclude is up to 15 to 45%, depending on the use of non-arable land, the fertility of the land, et cetera. So this is something that will get brought out, as this becomes more popular. How about water use? Well, if you look at water use of cattle, they're a big user of water. But in life cycle analysis today, you have to break water down into three types of water. You have to break it down into green water, blue water, and gray water. Green water is the water that falls on the earth, runs into a stream, and runs out to the ocean. Green water isn't a problem. You either have it or you don't. Blue water is the problem. Blue water comes out of aquifers, it comes out of dams. Blue water is used in your faucet, it's used to water golf courses, it's used in industry, and it's used for irrigation of agriculture. This is the big constraint. And then gray water is polluted water. So when you break it down that way, actually cattle are very small users of blue water, and they're a relatively minor producer of gray water, and that's mainly out of the confined feeding operations. And then, you know, the pushback on the emissions. Yeah, overall, there are big emissions from cattle, but take a look at it worldwide, where the red is very severe emissions, the green is very low emissions, and what you see is it depends on the part of the world which depends on the efficiency of production. So these types of things, there's going to be pushback. You know, the groups selling this have not come up with, they've done the life cycle analysis the way that will present the product in the best light. And we're only now beginning to get standards for life cycle analysis and how we might look at that. What about nutrition? Well, we see the slides like this all the time comparing it, and they basically show they're very similar. But let's look a little closer at nutritional considerations. Number one, sodium. Well, if you compare the sodium in the Impossible Whopper to the regular Whopper, it's not much difference. That's because there's a lot of sodium in a lot of the sauces and bun and so. But if you compare the sodium in the patties, there's an enormous difference. The Impossible Whopper has 370 milligrams of sodium per patty, based on a 4-ounce patty, the same size as Impossible Burger. From beef, it's around 80 milligrams of sodium. So roughly 5 times more sodium in the Impossible, in the plant-based. Iron bioavailability, the iron is, you know, the iron is using the leg hemoglobin, which is converted to hemoglobin. Most of the studies are showing it's bioavailable, but they're very, very limited studies on it. Does it have any impact on other, especially divalent cations? We don't know. So, I mean, there's got to be more work on that. I'm not suggesting that there is a problem, but it hasn't really been studied. Here's one of the things that I think is a potential problem. This is just a snapshot off of our database of what's in burger. What's in burger is a lot of things. We actually have about 125 things on the page on what's in burger. So burger is a lot more, animal source foods are a lot more than protein. Are the plant-based going to meet the other components that we get out of the animal base? And this is a big consideration down the line. How about this? The clean label. How is that going to stack up? We've heard consumers want to see clean labels. So let's take a look at a plant-based burger. You start with the field, you harvest the field, you go to the protein, you go through a bunch of steps, you isolate the protein, you denature the protein, you chemically change the protein. Meanwhile, you start with a batch reactor, you get the leg hemoglobin, you convert it, you add in the sodium, spices, and flavorings, and voila, you have a burger. How's the animal industry going to respond to that? You start with a cow, you get the meat, you grind it, and you've got the burger. So, I mean, this is, as it gains traction, these are the kind of questions that are going to have to be addressed. So, opportunities and challenges for plant-based meat. One of the challenges is that burger is still considered, most burgers are fast food. Sure, there are burgers we cook on the grill at home, which can be healthy, but most of them are as a fast food meal, high in fat, high in added sugars, very high in calories. There's going to be pushback over the nutrition and sustainability claims, and then you've got to admit it, it is an ultra-processed product. How are we going to get around that term of ultra-processed for people that don't want that? Opportunities, there's great opportunity for novel plant ingredients here as consumers want some of these novel sources of protein. And then another big one is as meat extenders, which really fit into the flexitarian lifestyle. Not a full plant-based burger, but you have your burger, you add your meat extender to it. It cuts down on price, it cuts down on cost, and you cut down on the total amount of animal protein. Let's move on to another one that's very similar, that's cultured protein. We've all heard know your farmer, know your food. I think here we'll have to say know your batch reactor, know your food. So I don't know how many of you have seen this. That's been floating around. Rethink X, it's a critical piece out of a techie group. And, you know, their big thing is that by 2030, the number of cows in the U.S. will have fallen by 50% and cattle farming will be all but bankrupt. And that's because by 2030, batch reactors will be able to make all the protein we need. In fact, they don't stop there. They say it'll make all the food we need. And this is just a graph of what they see over the time that the demand for modern beef, which it's not going to be beef, modern cultured, whatever you're going to call it, will increase and the demand for old-fashioned will go down. All right, well, you know, that's crazy. Well, is it? I don't know. You know, 6 years ago, this guy, Rob Reinhardt, called Dave and I and asked us about this stupid product, Soylent. I just read an article yesterday. He will be a billionaire in another 2 years. So don't tell me that there's not a big section of and Dave alluded to this, you know, young people, a lot of the younger generation is willing to do this. And Rob Reinhardt, he really points out there's no need to eat anymore. You know, it's just a waste of time. Let's just go to where we can quickly grab something, drink it down, and that's all we have to have. One of the problems I face here is if batch reactors can make animal protein more efficiently, why not plant protein? So think about it. The food we eat today is certainly not the same as the food that was eaten 100 years ago. But the food we eat today is related to the food we ate yesterday. And the food we ate yesterday is related to the food we ate the day before, and so on and so on. It's been incremental changes. And we have started with agriculture, stayed with agriculture, and the base product has remained fairly similar. This is a massive evolutionary leap that, you know, we're going forward where we're just going to recreate the foods. So in general, so I will skip to, what happened here? Oh, okay. In general, they're the same questions for cultured meat as for plant-based, so it's going to happen in the future. It's ultra-processed. Then there's price, there's unsettled regulations. And very quickly, I want to bring up one other thing that really, I think, does have a big potential impact, and that's indoor agriculture. Vertical farming. The problem is, at the moment, vertical farming is limited to leafy greens, tomatoes, but there are many groups working on other crops that can go into vertical farming systems. And I really see vertical farming as potential down the line. One of the things fueling it is LED lights are becoming much more efficient and much, much cheaper. And this is really fueling the rise in that. Along with that, aquaponics, where you raise fish with it. Right now, it's fairly unprofitable, but this slide shows that aquaponic groups think they're going to be successful in 36 months. So the opportunities and challenges, the opportunities, you can make it local, you can make it fresh, it's less water use, smaller footprint, no runoff of pollution. I really see some real potential. How much it'll dig into the protein, that depends on the crops. And I mentioned these. So overall conclusions, the new technologies that we're seeing today are pushed in part by hype, misinformation, and bias. And there's bound to be some pushback on this. Conclusions are often based on worldviews. The mass market is going to draw FDA regulatory attention. You need to concentrate on the strengths and eliminate the weaknesses. Some approaches have strong niche socioeconomic appeal, but what will they do for 9 billion? And finally, emerging technologies such as insects and indoor ag need protocol and product standardization. So I'll end it with this. You can have, in a chess game, you can always make a bold move and disrupt your competitor, but if you don't understand what that move's going to do 5 or 6 moves down the line, you can be in a much worse situation. And with that, I'm